Hey everyone, in this video we're going to talk about interval and set notation. So by the end of this you should be able to express a list of values in either notation. And as always you might be asking, why do I even care? Well, honestly, interval and set notation on its own is just a notation. It's kind of like when you're learning languages and you learn like words and structures. Same thing goes in math. When you're learning a notation, you're learning how to speak the language. Okay, so on its own, it's not that useful, but once we learn to speak the language, we can then use it to describe any set of values. And for the purposes of our class, that will be useful for describing functions, specifically the domain and range of functions, which we'll get into later. But right now, I'm going to teach you how to speak the language for us to then use later, if that makes sense. So now you might be asking, what is each notation? And I've given you examples right here. Highly recommend you label them and write these examples down. So first we have interval notation. Here's an example of interval notation. You have this bracket, -3, 10, parenthesis, blah, blah, blah. In general, interval notation, you're always going to write your lowest number, then comma, your highest number of a set. Okay, again, that's a number sign, not a hashtag. So when I say generalized, that means like not a specific example, but for any case. So that would make this the lowest value in the set and this the highest value in the set. And then you're either going to have parentheses around that, or it could be brackets around that, or as you see here, you could have one of each. So you could have parentheses or brackets, probably not both, but I don't know how to write that. We'll generalize that in a second. Okay, what does that mean? So you heard me say this is the set of numbers. I'm going to plot this on a number line so you can kind of see what this means. So the set of numbers, -3, 10, means all numbers from -3 to 10. So that's -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And all the numbers in between. So like 1/2, 0.97231, like all of the numbers in between. So if -3 is here on a number line, and then like 0 is here, and then 10 is like here, we're looking at all the numbers from -3 to 10, where -3 is the lowest and 10 is the highest. Okay, we just express it using interval notation to make it, more like formal and concise. Okay, now you're probably wondering, well, Miss Mancini, you said it could be a parenthesis, it could be a bracket. Like, how do I know which is which, right? Maybe you're not wondering that, but I don't care because I'm going to tell you anyways. So when you see a bracket, that means that value is included in the set. Make sure you write this down. Versus when you see parentheses, that means that value is not included in that set of numbers. Okay, I should say set of numbers, however you want to write that is fine. Okay, so going back to the number line, right, I said it's all numbers from -3 to 10, so everything would be included in that set, which we can talk about all different kinds of sets of numbers in math, eventually domain and range. So as you can see, -3 has brackets here. And what that means is -3 is the number is included in your set. So on a number line, to include it, we would draw a circle around that that's filled in to show that -3 is part of the number we want. Whereas 10 is not included in the set, which means you go all the way up to like 9.999, but you're not actually going to include 10. So at 10 is the boundary, just like -3, but this one's not included, so we would throw an open circle around that. Okay, so closed circle means included in the set. Open circle, and that's a really big open point, but you get the idea, means not included. Okay, which included is a bracket. That's not a good bracket. Included is brackets. Is that a better one? Not really. Let's try one more time. Included is brackets, and not included is parentheses in interval notation. Okay, so that's one way you can describe a list of numbers, is just listing it as your lowest bound or your lowest number in the set, comma, your highest number in the set. Okay, which could be a concrete number like -3 and 10. It could be infinity, which I'll show you in a later example. Set builder notation essentially means the same thing. So I'm actually going to start with this drawing. Notice we have the same bounds as this one. That's because these mean the same thing but in different notations, which will help me compare. So let's put -3 and then 0 and then 10. Why did I write that on the number line? There we go. Then 10 here. Okay, so let's read this for a second. So you have x bar, -3. This symbol means less than or equal to x is less than or equal to 10. Okay, generalized set builder notation will always have these curly brackets, which I struggle to draw. Okay, it will always have some variable to define the set, and then some bar here. So this would be your variable, right? That would be your bar, and then an inequality statement to describe the list of values. Okay, that variable could be anything. If we're talking about domain, it'll be an X. If we're talking about a range, it'll be Y, but that's a preview of the next video. Okay, so that's the general way to write set builder notation. It still means the same thing. So this is a compound inequality, which means there's actually two inequalities in one. Better yet, let me get some highlighters to show that. So that's not a highlighter. So here is one inequality, and that inequality says, give me one second. That inequality says -3 is less than or equal to x. Or if you flip that around, it looks like this, right? So that means x is greater than or equal to -3. Think about this as like an alligator. It's facing the x. It wants to eat the x. That means x is greater. So that means all values greater than -3. So that'd be going like this way. Okay. But it's a compound inequality, so there's like a second half to this, and that's where the 10 comes in. So the other part of this inequality is x is less than 10. So on the number line, we want all values that are less than 10. But since it's compound, you want both of these things to happen, which makes all the values in that set between -3 and 10. Just like this example over here. These, again, mean the exact same thing. Okay, which also you might be wondering, like, okay, if they mean the exact same thing, would I put a point here and an open point here? Yes, you would, and let me explain why. So just kind of a quick notation summary. You'll notice here that I use two different symbols. One has less than or equal to, one has less than. So symbols like this either mean less than or greater than and equal to. So consider this kind of like, okay, here are the symbols for less than or greater than. They don't have an equal sign. So less than or greater than with no bar underneath. That bar kind of like means part of an equal sign. That's how I remember that. So if you have just less than or greater than, that doesn't mean it's equal to as well. So that would be a not included scenario. Kind of like the parentheses were also not included, or the open circle. Okay, so this symbol means less than or greater than. That means not included, similar to the parentheses or the open circle. Whereas this one with the line underneath is like part of an equal sign, means also, let's not use an equal sign there. Line under means also can be equal to. So if we were less than or equal to -3, that means it could also be equal to -3. So that would be included, which is like the brackets or the closed circle. Running out of a little room here. Close circle. Okay, so just to highlight that real quick, one more time. Included, closed circle for equal to ones, not included, open circle for not equal to ones. But these mean the exact same thing. They're just two different notations to describe sets of numbers. And you will use both, so I'm going to show you how to use both real quick. So the question says, convert the following interval notation into set notation, then sketch a number on the number line. I actually like to sketch this first, even though I told you to do it backwards. I think a visual helps me. So 0 would be here in a number line, and then -5 would be, I don't know, like over here. What this says is -5 comma infinity, which infinity means you go on forever and ever and ever in the positive direction. And by the way, negative infinity would be forever and ever and ever in the negative direction. But since this is an interval notation, that means this number is the lower bound or the lowest number you can have in the set. And this is the upper bound, or better yet, the highest number you can have in the set, right? That's what we talked about above. So to sketch it on a number line, -5 is the lowest number it can be. And then note the bracket. Bracket means it's included. So -5 is part of our set, so we're going to fill that in. And then the highest thing it can be is infinity, which means we want every number going all the way to infinity. Would look something like that. The arrow implies forever and ever and ever. It would never stop. And you'll notice that at infinity, there is going to be a parenthesis. That's because you can never really include infinity because it's not a number, it's a concept. So you will always have parentheses on infinity or negative infinity. Oop, that's an 8. Or negative infinity. Okay, so just a little note to you all. So now that I've drawn that on a number line, I want to convert it to set builder notation. So in set notation, the first thing I always do is just kind of write out the structure. So we know in set builder notation, we need a bracket, then we need a variable, then this bar. I'm just going to choose X since we're not in context here. X is like our go-to variable. So X bar, this bar means X values such that, and then you have an inequality here that tells you the rule. And just to describe what I'm seeing, I have -5 to infinity, which means I want all the values that are bigger than -5. So I want all the X values that are going to be bigger than -5. But we also know -5 is included because it's got that closed circle, because I had that bracket. So I don't just want bigger than -5, I want bigger than or equal to -5. And that would be the rule to describe my number line here. And that's how you'd convert it to set builder notation. Okay, something slightly different here. I'm going to sketch this on a number line, and then I'm going to let you try putting this into interval notation. So now we have set builder notation. We're using y's this time as our variable. So it's y's such that y is greater than 3. So if here's 0, here's 1, 2, 3. Oops, we're not going to draw a circle there yet. Or less than or equal to -1. Okay, so we have y values greater than 3, not equal to 3. So we want the open circle and anything bigger going to infinity. So it'd go forever and ever in that way. Or we want y values less than or equal to -1. So it is equal to this time at -1 or less than that. So that's what it would look like on a number line. And you'll notice it's different than the other ones because you have like 2 distinct branches here. So I want you to think for a second about how you would convert that and write that in interval notation. I'm not going to say anything. I want you to write your answer, and I'll come back to confirm or deny. No cheating. Okay, here are my answers, and I want to talk this through and see what you think. So, whoops. I had 2 distinct branches here, right? So I looked at one at a time. So in this branch, I have everything going increasingly negative, right? So I'm going all the way to negative infinity out here. So the lowest thing it could be here is negative infinity, and then it stops at -1. And that would be included because it's a closed circle. So with that said, I wrote that as its own interval because I had a clear ending point in negative infinity and a clear ending point on the other end at -1, close bracket. Then over here, it was there was a gap. So this had to have a stopping point, and then it kind of started again. So I wrote its own interval. So we started at 3, parentheses because it wasn't included, and went all the way to infinity, and again, parentheses on infinities. And that's actually the correct answer, is when you have 2 branches or 2 intervals, so 2 inequalities, you'll also have 2 intervals. And oftentimes you'll see it written like this. Okay, you'll see it written as negative infinity to -1, just like I had, and 3 to infinity, again, just like I had, but with a U in between. And that U is actually U for union. So like you're uniting the 2 intervals. So that's how you'd convert between interval and set notation. That is what interval and set notation is. We will use this to talk more about functions, specifically domain and range. If you have any questions, please let me know. Otherwise, look forward to practicing.